and start with a maybe just a little bit of 为什么我觉得有点奇怪 Is it really working? Ah, 我弄错。为什么？哦。谁呀？对不起。Okay, I start with a little maybe introduction for how to work as a professional scientist. When we are doing presentation in conferences or when we are transferring our documents, and maybe you should know that not everyone is using the Windows system. And most of the people in science and engineering will start to work with Linux systems someday. And you know that if you work with the Windows Office systems and like, I don't remember the application name, Word, PowerPoint, Excel, or some other softwares. And sometimes when you're doing documents with it, but if you open a document in another computer, and usually your text, your graphics, your especially mathematical formulas, they just explode and they just go away, and they cannot fix on the position that you want. So we usually convert our files into PDF files, and then we transfer PDF files everywhere. So just to train yourself and get new habits or get a new skill. And every time when you are sending your reports or sending your presentations to someone else, and always convert it into PDF file. 好，先跟大家讲一下，就是大家开始做那个，你开始成为一个专业的理工人之后，我觉得其实用 Windows 系统的人很少，大部分人会开始用苹果电脑，因为有些做视觉的或是做写程式的，用苹果电脑确实比较方便。然后等到你开始进入真正的专业领域之后，你一定会用 Linux 的 system， 尤其是你在做 Great Computing， 或是像我们这些做科学的，你要做很多科学运算的时候，用 Linux 系统是比较方便的。那我们就会开始用这些别的作业系统、别的应用软体去做我们的科学文件嘛，不管是写报告，然后或者是做成片。那因为这些作业程式，它们的程式都不相容，所以你的报告如果是原始的那个档案的话呢，你拿到别人的电脑上，通常基本一定会炸开。那请你要养成习惯，把你的档案转换成 PDF 档之后再传给别人。不管是传给指导教授，或是传给你的同学，或是传给你的 team member， 对，就是要会使用 PDF 档，这个是做科技人的基本功哦。对，所以请大家从现在开始要那个养成习惯，就是传送档案的时候都用 PDF 档。还有，如果你还更有兴趣的话，请从现在开始练习写 LaTeX。就是有一个软体是写报告跟写论文跟写数学方程式用的，它的门槛有点高，但是你的那个门槛跨过去之后呢，你就会觉得就会写报告就很快啊，因为它排版就是它会自动帮你排，然后你不需要再去在意说，就是我的图什么样怎么放啦，然后写数学方程式，然后你也不用担心你的方程式会炸开，所以大家趁现在还好像相对啦比较自由的时候。就可以练习一下这些 soft skill， 不然等到你要开始考研究所，那个时候可能很忙，可能就没有时间去练习这些重要的技能。好，今天的上课从我开始 ，so I start the lecture today, and then I will invite the presenters. Okay, so everybody already get the big tables right. Okay, good. So first I would like to introduce what is energy. Now we are coming into a very important point in physics because since now we are going to work with energy every time, everywhere, for every cases. Energy is something much, much, much more general than force. So usually energy is the beginning of everything, and if you would like to derive something or analyze something, you always have to start with the energy, because energy will tell you the reason why things go that way, why things arrange themselves not that way, or why an action A turns into the result B, like that. And that is always related to the analysis of energy. And here is the table, and this is the blank that we're going to fill in. Okay, but the most interesting thing in physics about energy is like this, and I think Richard Feynman said it really, really well. I suppose everybody knows who he is. And he just said that we should really realize in physics today, even up to today, we have no knowledge of what energy is. This is true. We really don't know what energy is. And if you look through the story of physics, and we do not really have a concrete picture about what is energy, because that is not something that you can touch, that is not something that you can see. You cannot see it, you cannot touch it, you cannot, can you create it? Not really. You can transfer it, but you cannot create it. And it just somehow came in a way that when people are doing experiment and when they're doing analysis, they just simply find out that if they do some calculation, if they define some numerical quantities, and if we put all of these numerical quantities together, just add up, just do a summation, and we find that it gives always the same number at the beginning of the action, at the end of the action, and somehow this number, the energy, is always the same. And people just discover it, and they find it's such a magic, and it's very fascinating. And therefore, we started to use this concept, energy, a lot. And this is a very abstract thing. It's not a solid thing, it's an abstract thing. It's sort of a human's imagination. And but it really do work. And that does not tell us the mechanism or the reasons for the various formulas. I think the last sentence is very important. It's like energy is something that we calculated, we sum them up, but it doesn't really tell you the reason, and it doesn't really tell you the mechanism. But this is something that you can use, this is something that you can apply. The conservation of energy is a very important rule in physics. So, yeah, I think that's it. So sometimes, I don't know, sometimes people, they use a term of energy like, I don't know, like God, or like, I don't know, the reason for something, but I think that's a little bit overvalued. That's a little bit too much. So, yeah, okay, so we can take it easy. But here, I would like to talk about conservation. I think the fact about conservation is really interesting, and this is very important. So we can imagine at the beginning of our lecture, I just showed you a little video of a firework. And here's how the firework is exploding. So this is, you can imagine here, or maybe you can call it a little bump. The little bump is moving and it's carrying some material inside, and if you burn that material and that material starts to explode, it creates a lot of gas, and then all of these dust, they just rain out. And this is the status before the explosion. And this is the status after the explosion. You can call it, this is the initial state, this is the final state. And if you calculate the energies in here, and if you calculate the energies in here, if you compare them, you will find that the energy is the same before the action and after the action. And here are many contributions to the energy. Kinetic energy, potential energy, internal energy. So you should find the the energies inside, what kind of energy is involved in the action, and then you try to calculate it and you try to sum it up and you check if it conserves. So this is usually what we do when we are analyzing the physical system. And here I am listing something that we thought they conserve, and maybe up to now they are proved to be conserved, but there are possibility they could be violated. So here are, for example, mass conservation. The mass before and mass after the interaction, they conserve. Energy conserves, momentum conserves, electric charge conserves. So we can calculate the positive and negative electric charge and see if they conserve. And then here are some things that people are not quite sure. Maybe if we do more experiment and then we will find it out, but for the moment we assume they conserve. For example, the left and right symmetry, but actually this is already violated. This is a very famous experiment done by Wu Jianxiong, and which leads to the Nobel Prize of Yang Zhenming and Li Zhendao. So this is actually already violated. And rotational symmetry. Yeah, this is something that we are still considering they are conserved. And the future and the past symmetry. So you can see that there are many symmetries and there are many quantities, and we consider them conserved. And when we are analyzing our system, if we are checking something and if we want to say if it makes sense, or when we are deriving a action. So I understand this is the initial state, and now I have a bunch of energy. Then I have to think, okay, so what could be the outcome? Then you should apply these conservation laws, and then you start to derive and what could be the future. 这边我用中文再说一遍哦，就是所谓的守恒定律，在对物理学家来讲，其实物理学的研究就是一连串寻找守恒定律，然后再把它打破的过程。对，所以你可以去看我们那个近代物理学发展，我们有一段时间，尤其是1970年代的时候，所有的物理学家像疯狂的一样，一直不停的在找守恒定律，但是有一些就是被打破嘛。然后像那些理论跟实验，它就变成了近代物理上面一些非常经典的 case。那么先列出几个经典的，质量守恒、能量守恒、动量守恒，还有电荷守恒。前面4个到目前为止，大家应该是都没有异议的，因为我们都已经做过很多实验，然后确认这些守恒定律是到目前为止都还是有。好，然后再来呢，左手跟右手的对称性，这条守恒定律已经被打破了，那就是非常有名的那个吴健雄做的实验。然后呢，他们就去对李政道跟杨振宁来讲，它就变成一个灵感，他们去改写下那个基本粒子物理学的公式，然后用那个公式展现出左手跟右手的对称性什么时候会被打破。这个就是宇称守恒定律，然后还有宇称守恒，对 violation 的中文是什么？忘记了，好，没关系。然后再来呢，旋转的对称，到目前为止好像还没有人，就是没有人有意见呐。它有一些极限。就是旋转的对称性，如果你考虑质量的话，旋转的对称性就不能适用。但是现在的物理学家用希格斯定律暂时用相变，就是糊弄过去了。对，那以后应该会找到更完善的定律吧，我是这么期望的啦。然后还有一个是现在未来跟过去的对称性。这个就现在有很多实验正在进行中，那这个有点超过我本人的专业的领域，所以我就大概先说一下，但是没有他讲的更深的，抱歉。那你如果对于这些守恒定律的故事很有兴趣的话，你可以上网去找一下。我是觉得这些故事非常的有趣。好，再来，好，那么我们就请 Then we invite invite the student to solve the first question for today. So now we would like to show you the types of energy. and ways to transfer it.
好，那我们就请今天第一位同学来帮我们跟我们分享。那请他介绍，能量的有哪些种类，还有能量如何传送。
So I'm going to explain the question one. The first one is the energy transformation of television. And firstly, the electricity will go through the wire and come into the television, and then the energy will transform into sounds and light, and some parts of the electricity will turn into thermal energy, which is 热能. And recently we use the television LCD TV, and which is 液晶电视. And the principle of it is the electricity will change the direction of the liquid crystal, which is 液晶, and it will change the light we see. So we can see the changing of light on the screen. The second question is the grass mower. And firstly, the energy was initially is electricity, and part of it will turn into the kinetic energy of the grass mower, which is 那个除草机的动能, and other part of it will turn into the thermal energy. And the third question is tea heated in a microwave oven. And firstly is also the electricity, and it will turn into the electromagnetic wave, which is 电磁波. And the kind of the electromagnetic wave is this microwave here. And the microwave will let the particle of the tea starting to vibrate, and the particle of tea will collide to each other and turn into the kinetic energy, and the kinetic energy will turn into the thermal energy.
Just a little remark. Sometimes when here she called it kinetic energy and thermal energy, but sometimes, especially when we are working with statistical physics, or when we are working with thermal physics, and then we call them internal energy. When how the molecules collide to each other, and how the molecules rotate, and how the molecules vibrate, and we put them into the category of internal energy.
No. And the first question is riding a bike. Firstly is the chemical energy in our body, which is ATP, and some part of it will turn into the kinetic energy we moving our body, and the movement of our leg will turn into the mechanical energy of the bike, and some part of the chemical energy will turn into the thermal energy.
So you think the chemical energy is from yourself, from the food that you have?
Yeah.
and the food turn into the chemical energy. And somehow your brain use that energy and then move your arms and move your legs. And then those movement of the arms and legs, I think here is one more step between the chemical energy and the kinetic energy, and that is actually the work. Yeah. That's okay. 就是跟大家讲一下，他这边说那个你吃的食物，然后呢那个食物的能量嘛，然后我帮他补充，就是你的大脑会让你使用这些能量去移动你的手，移动你的脚，然后你的手跟脚跟脚踏车之间的互动呢，其实就是一个做工的过程，就是 work。好，所以其实 chemical energy， 然后会你在中间加一个 work， 然后那个 work 就会跟你说你的脚踏车往前动的动能，然后还有可能会摩擦会生热，对，会有热能。所以中间还缺了一个 work 这个过程。
In the fifth question is driving a car, and electricity in our car will initiate our engine, and it will make these things move up and down. And when it goes down, it will absorb the gas here, which is the chemical energy, down to here. And when it goes up, the engine will set fires here, and which will cause an explosion. And the pressure will make these things goes down, and then it will make a circle of up and downs here. And the movement of up and downs will cause the mechanical energy of the gears, and which will make the car move. And some of the energy of chemical energy will turn into the thermal energy here. And the sixth question is called by phone, and I'm going to separate this question into two parts. The first part is the voice in. First, we will get electromagnetic wave into our phone, which is radio wave or light. Light is an energy comes from optical fiber, which is 光纤, and other way is from electricity. And this kind of energy will transform into electricity, and you can see here the electricity will transform into the magnetic force, and the magnetic force will make the board here vibrate, which is the kinetic energy, and the vibration of the board will turn into a sound we hear. And the second part is voice out. We say something to the phone, and the energy of sound will turn into the kinetic energy. You can see here the energy of sound will vibrate this board, and the board will make a particle here to change the size of the electricity, and the electricity will goes out to come into the electromagnetic wave, just like the voice in. Also the electricity. The seventh question is information through internet. We, no matter what kind of information, we will all store them into a memory place. And how do we obtain the information here? We can get them through electricity or electromagnetic wave. Electricity is go through from wire and electromagnetic wave like microwave 微波就是 WiFi， 然后还有 light 就是用光线，然后and then this energy will transform into electricity and go into our device, and we can see the light project on the screen.
Just a little remark about the memory. Do you know how memory works? I mean, a solid thing memory. That is actually in memories there are a lot of little magnets, and that is we measure it by the spins of the electrons inside the atoms, and then actually we are flipping the spins of those electrons, and then the status of the spins turns into 1 and 0, and then you can put all of the 1 and 0 together, and then you can do some algorithm, and then you track your information out. And that spin of the electrons, I guess, is kind of internal energy. I don't know. Maybe when you're reading textbook or some other things, they have different kind of explanation. That is my point of view. 我这边稍微说一下，大家可以去研究一下所谓的记忆体是什么东西。那目前为止比较新的记忆体应该是使用一些磁性物质，然后那个磁性物质之所以有磁性，就是因为里面的电子它们有自旋，然后那个自旋会有很多种不同的状态嘛。那我们就是透过调整那个所谓自旋的状态，然后去界定说我们现在的数字是0还是1，然后那些0用二进位的各种排列组合，你就会开始做运算，然后这些运算你给它编码之后就会变成你的数据。那么，所以我会觉得，其实，在前面那个 memory 的状态里面，其实里面有那个 internal energy， 就是分子本身或是原子本身里面那个电子它本身的状态。那个状态这样变来变去，前面应该是internal energy 吧，但是我不太确定现在的 textbook 或是别的东西有没有 update。好，
这个照片有点怪怪的。
哪个照片？
如果是 memory 那照片没错。
我感觉 hard disk.
Hard disk and USB. I don't know. It depends on your point of view. Maybe you would like to see the atoms, and we can go to Professor Lin Junliang's lab and ask him and get some pictures. Yeah, I think that's something inside. Maybe that is just the shell. Or what do you expect?
This is hard drive.
Hard drive. Yeah. Maybe if you open it, then you can see the memory. 你可能把它打开。其实我没有开过因为我们都不敢开。Actually, we don't have the guts to open it. If you open it and then if the dust comes in and then it doesn't work anymore, so I never opened a hard drive for myself. Maybe if we get a broken one and you can try to see how the memory looks like. 好 ，OK。
And the next one is waterfalls. We can see that the water has an initial energy, which is kinetic energy, and its potential energy. 这是位能的意思。在最上面的。And when it falls down, it will turn all into the kinetic energy down to here.
Maybe one more put. I don't know. Maybe when the water is tumbling, and then the molecules of the water they just they get friction between them, and that kind of friction can generate some heat, and then I don't know. That could be the internal energy of the molecule, but getting out of the system in the form of heat. 这边也刚刚稍微说了一下，除了那个分子本身从高的往低的，它会有位能，重力位能会牵涉其中。还有一个是那个分子在跑的时候有动能，还有一个是那些水流这样子互相滚动的时候，它们之间会互相摩擦嘛，然后那个摩擦它有时候会生热，所以它其实它的状况应该有一部分那些水的内能会用热的形式散发出来。好，所以这是additional remark。
And the last one is water cycle on Earth. We can see, firstly, we get the energy from sun, which is solar energy, and it will make the water here thermal energy it will make the water evaporate, and when it becomes a cloud, it will get potential energy here, and when it rains, it will turn into a kinetic energy, falls down to Earth, and then it will comes to water here, and then it will make a circle.
For the solar energy, and maybe a little bit deeper, that solar energy is, why is that? Kinetic energy, no. Potential energy, no. Internal energy. Sorry, I'm a little bit stuck. I am not able to put the solar energy into any category of it, but the only information I have is that the energy from the sun is transmitted by electromagnetic radiation. Yeah.
So this one is the electromagnetic wave.
Yeah, that's the way to transfer the energy. But no, I'm just stuck. I don't know if it's, no, that shouldn't be the kinetic energy, shouldn't be the potential energy, not the internal energy. Maybe you can call it internal energy from the nuclear interaction in sun. Could be. Yeah.
Okay, and this is the table of the question above.
So that is your summary table. Okay, maybe you can leave the first table on there for a while and touch base, take some notes.
Thank you for listening.
So Now you can see that the TAs, they just summarize all the information and then put them into the table on the right hand side on the blackboard. And you can see that the big table is divided into two big columns. On the right, the delta K, delta U, delta INT, that is the three types of energy, or you can say three forms of energy: the kinetic energy, potential energy, and internal energy. And on the right hand side, the W, Q, and T, four kinds of T, that means the way to transfer your energy. So keep very clear in mind the big columns on the left and the big columns on the right, they are different things. So K, U, and EINT, you can think of them as the characters. And on the WQ, and this is how you transfer them from one place to another place. So they are different things. 好，大家要注意，就是我刚刚请助教，然后把同学的资讯整理在那个大表格里面。然后呢，我们知道有动能、有位能、有内能，这三个是三种能量的形式，我们目前的能量的形式。然后再来呢，右手边那6个是如何传送能量。所以能量本身跟传送能量的方法两个是不一样的事情哦，大家不要搞混了。然后呢，有 W 就是做功 ，Q 就是热，然后还有4种 T 有4个方法，我请那个来解释一下。
First one is mechanical wave transfer is for机械波。
举例 ，for example， look at the table, there are no local sounds.
除草机吧，除草机是最明显的。The gas mower, and the second is material.
I guess the scissors in the gas mower, which is around, and that is a kind of mechanical transfer.
Force, like a force.
Yeah.
And the second one is material transfer. Is chemical transfer like the power.
Oh, wait a second. The mechanical wave transfer, there is a very important member, the sound. In the category of call by cell phone and sound, sound is the vibration of molecules, isn't it? The vibration of air molecules, the vibration of water molecules, and this is how the energy is transferred in the form of sound. So that is a kind of mechanical wave transfer. 就声音也是一种用机械运动传送能量的形式。这我刚刚一直很想讲，但是没有找到过考。好。OK。
TV also has sound.
Yes.
And electrical transmission is for electric,就是一些电能的转换。然后最后一个是electromagnetic radiation， 就是我们常听到的电磁波，就是其实很多电器都看得到。Also light, 那个光。
Yeah, light is in a family of electromagnetic wave radiation. No. Okay. Yep. 再请下一位同学。
The next one. Problem 2.
So in this problem, I would like to show you this, give you a taste about how you analyze if the energy is conserved. Though we have not derived the equations for all the energies yet, but I suppose you already learned a little bit about it in the senior high school, so I don't think that will be a big problem for you to recognize them from the equations. But the point in these three problems is that please look at the indices of the energies and please look at how they conserve. 好，那在这一题呢，虽然我们还没有很正式的推导动能跟位能的公式，我们接下来会用向量分析去推导它，但我相信你们在高中的时候应该多少都已经有学过一点概念了。那大家在看这个题目的时候，请大家要注意，就是这两种能量是怎么样的守恒的。好，我们是用什么样的方式去分析它们的守恒，然后我们是怎么样应用守恒定律去分析它们的运动。OK。
Hello everyone。我先前情提要一下，就是这一题我其实全部都是用高中的方法在解的，所以，然后你也知道，大家也知道，其实我们现在离高中有一小段距离，尤其这个力学的部分是在高二的时候学的，所以有问题就是请直接举手纠正我就可以了。用中文拜托，不想增加沟通的困扰。对，而且应该会错不少地方，所以这是你们加分的机会。然后体谅一下，就是因为这个图形，我的绘图能力没有很好，所以我都是用板书，所以辛苦各位了。各位有看过题目吗 ？Have everyone know the question? Know the exercise about this one? OK， 没听到吗？其实我讲很快，所以没什么关系。
有问题，你有把手碰得好快哦。See how the mouse moves？
你那太高了。
OK， 那可能第二题。The second one, yeah. So today we are going to talk about conservative force and isolated system. At first, I want to, we have some definition needs to know. So first one is what is conservative force? Actually, conservative force is a force with property that the total work done in move from the total work done in a move a particle between 2 points is independent of the path taken. 就是你只要在两点之间移动，然后不论路径上做的功都是一样的话，那个力我们就叫做保守力。对，只是那个字其实是念，其实是守恒跟保守，所以我就觉得分守恒其实好了一点，就是台湾就把它分成保守。对，所以我就觉得，就是当初在理解上面有点困难。对 ，so so informally, we can say that a conservative force can be thought of as a force that conserves mechanical energy. 就是力学的守恒或者是机械的守恒。And mechanical energy is composed of kinetic energy and potential energy. Yeah. And there are some examples of conservative forces like gravitational force, spring force, magnetic force, and electric force. Yeah. And there are some classic examples of non-conservative force such as friction, 摩擦力 and drags 阻力 and why frictions are non-conservative forces. It is easy to say that because friction is this one depends on pad 路径场。
Yeah.
There are common questions in high school is that you push a box around the circle, and they are asking how friction affect the box. Yes. So, and another definition is an isolated system. What is isolated system? An isolated system is a physical system so far removed from other systems that force and matters do not interact with them. So it means that there will be no interaction between inside and outside of the system. And energy inside the system will be conserved because there are no interaction. Okay. So after some definition, let's go down to the exercise. And at first I want to clarify that we don't consider frictions and drags because the main reason is both of them are non-conservative forces, and another reason is the situation will be too complicated if we consider both of them. And the describe has said that the bees work on a smooth table, so I think we don't need to consider about frictions and drags. So the first one is here. Plastic bee swinging on a half pipe. And we often see this on the test when we are in high school. So I think this is easy for all of you. So this is mechanical energy. It's known as kinetic energy plus potential energy. So we say that this is the first place we call the spot of zero, the initial point. Yeah. And so first, we assume that the beat stopped at there. We have an invisible force to hold the beat. And now, so far, the beat only has potential energy called mass, time, gravitational energy.
Gravitational. Yeah. Gravitational acceleration.
So MG is yes. Okay. MG is yes. So
you're using me as a Siri, isn't it?
so and then the invisible force disappears. So the beat starts to drop, and the beat have two forces interact with the beat. One is the gravitational force, also known as gravity, and another one is normal force, 正向力. And we all know that normal force only change the direction, but do not change the speed. So actually, the only one which affects speed is gravity. So when the beat drops to the point here, 第一个点，我假设它叫第一个点，对。So there are some connected. Actually, it's hard to just 算出那个点的动能 because it's hard to assume the velocity. So we can use the 那个守恒 conservation of the energy. So we can take the potential energy first. So the height change from H0 to H1. So the potential energy decreased into mg H1. Yeah, so we can say that the kinetic is the total energy minus the potential energy at the spot 1. Yeah. So when the bead dropped to the bottom of the half pipe, and I want to say that 就是其实位能是一个被定义出来的东西，就是像这个地方，我是假设这个地方叫位能零位面，就是到这边的时候位能会变成是零。对，所以the potential here is 0, so we can use so we can get the kinetic at this point by using energy minus potential equal mg H0. However, we know that there are another way to get connected to this and the open sea and meeting. Yeah, so we have often used this 公式 to get our answer when we are high school. Yeah, so this is the first one. And the second one is plastic bead attached on the horizontal spring, vibrating on a smooth table. And just imagine this is a bead, though it looks like a box, but this is a bead. Yeah. So actually, we have a spring, and spring get a force. Is this one? This is a 常数, and it will change dependent on the 常数变化量. Yeah. So someone will wonder that is this path like the path? But however, this is 变化量, not 路径长. 有些人会觉得公式里面有距离，就以为那是
K is the whole constant. Constant 是常数 and delta x, that is the deviation between 2 points. So x1 minus x0, that is delta x. That is the difference between the x1 and x0. Or you can say that is the distance between x1 and x0.
Okay, so let's analyze this one. So if we again an invisible force push the bead to the place x1, and now the force the spring will give a force to decouple the invisible force.
To resist.
Yeah, to resist the invisible the invisible force. So now this is a minus sign on there, and I want to say that sign means direction. It means that the force of spring is opposite with the force, the invisible force. So when the invisible force disappears, the only force is the spring force. So the bead will be pushed back to the original point. However, there are
Inertia.
Yeah. So the bead will keep moving forward, and they got a velocity, and we can calculate the velocity through the mechanical yeah, because we know the first potential energy here is this one. So when again 我们定这个是位能零位面。
We said that.
Yeah, we said that this
we
is.
said here be the reference point.
So here the potential will become 0, and there are the potential energy transferred into kinetic energy. So we can use that form again, so we can get the velocity, and the bead keeps going forward. However, the spring will
Extended,
extended.
elongated.
So there become a force to become to resist the beat keep going forward. So when we go to the second point, and the kinetic will transfer back into the potential energy, and the kinetic will become zero and just keep vibrating. So this is the number 2, and number 3 is similar to number 2, but just yeah. So there are another rotation for 90 degrees. So there will be another force that will affect is gravity. However, gravity is a constant force. So the effect will be just there will be a constant increase through the position, and the vibration is as the same as this one, but you need to plus gravity. Yeah, so this is the end of my presentation. Thank you.
Anybody have questions? Okay, so then I'm making my remark.
So, yeah, I think his concept for the analysis is really clear. So I just point 2 very important points out, and he already pointed out, and I think it's really great. So the first one is, you can see that when you see through these cases, the conservation of energy is always associated to an isolated system. So you have to find a boundary for your isolated system, and then you can start to use the conservation laws. 所以我觉得他刚才讲得很好，因为他把一些最重要的重点都已经说明清楚了。第一个就是你有没有发现，能量守恒一定会跟封闭系统绑在一起，绑定，就这两个东西一定是绑定在一起的。所以呢，你一定要先界定一个非常清楚的界限，把你的 isolated system 框起来，然后在那个框里面，你才可以开始使用能量守恒定律。如果你的界限不明确，或是你的界限框不起来，你就不可以使用能量守恒定律哦，因为你只会制造出很多的 confusion. So you have to have a very clear idea about your boundary, and then you start to use the laws of conservation of energy. Otherwise, you are confusing yourself. You keep confusing. I'm sure you're going to keep confuse yourself. And then the second important thing is the reference of the potential energy is another thing that you have to define it by yourself. 所以再来一个是位能，你会发现位能跟高度的变化的关系，尤其是重力位能的话，那么但是呢，高度的变化要从哪里起算，你要自己定义。所以很多时候你只要选对你的位能的 reference point， 你的整个分析会变得非常的简单。所以这个是2个大重点，请大家一定要放在心上，因为很多时候大部分的歧义都是从这2个点爆发出来的。好，第一个重点，第2个重点，还有一个重点啊，第3个跟第3题有关系。第3题 ，so the third important thing is about the vertically vibrating spring. And I think the question B and question C is always something that makes people very confused. Though today he just gave a very quick explanation. I would like to keep the problem 3 as a, okay, we will derive it later when we finish the derivation for kinetic energy and the potential energy. We will go through the derivation together, and you can see how energy is conserved inside, and you can see how the gravitational force is taking its action. 好，那我们那个第三小题，我们在推导完动能跟位能之后，我会带大家推导一次。因为第三小题，通常这里的第二小题跟第三小题是大家非常容易，就是也是大家很容易会产生争执的部分。我会先跟大家说，那个第三小题呢，即使你把你的弹簧垂直的吊起来，你现在想说，哇塞，现在重力也参战了，怎么办？但其实重力它能够作用的范围很少，它在这个状况里面扮演的角色就很简单，它只是重新设定我的 equilibrium point 在哪里而已。就是你有个重力，然后你的弹簧可能原本这样，然后一直拉的比较长，但是呢，你的震荡的中心点，也就是 equilibrium point， 它就是单纯的被重力重新定义而已，它并不会影响到动能跟位能的守恒。那这个事情我们之后会再推导一次，对，我们在课上会最后就会用推导证明给大家看。So, okay, I just said that in the question for the vertical spring. And now the gravitational force is getting into the game, and then you might get a little bit confused. But don't worry, the gravitational force is just redefining the point of the reference point of your vibration. The equilibrium point is redefined, but it doesn't really change how the energy is conserved. So the kinetic energy plus potential energy is always constant. And the potential energy and the kinetic energy, they are converting to each other constantly. This fact is not changed by the gravitational force. And we will do the full derivation and prove it to you later in our lecture when we finish the derivations. Okay. So let's take 10 minutes of break. And the third question, we will do it in the next lecture. Right? Okay. 那我们第三题，我们就下次星期五上课的时候，好，我们再来讲这题生活化的题目。我们先休息10分钟。
你带来的麦克风是不是没有声音啊？你说在哪个区域？电子波、除草机、电子波、除草机。等一下，我忘记除草机。除草机有用到光吗？没有。它有声音嘛？它有任何地方是用 radiation 吗？我刚刚心里想的是，假设说你有一个那个遥控器，然后你是遥控的，那个遥控的配置，就是会有一进到那个太阳能。对，但是我突然忘记，台湾的除草机大部分是用推的，对不对？而国外的除草机有一些是用遥控，对，我在想它可能是用遥控。
所以像 riding a bike 这我有个就是从化学ATP 要变成 ATP 要对，
如果你一边吃香蕉一边吃。
它的 ATP 不是能量，它的 ATP 是要变成 ADP， 才会有一个间断掉之后才会能量发生，这样是不是？
那个是食物已经进到你的身体里面，正在消化，真的是。
应该说它原本储存能量的方式是 ATP， 然后它需要使用的时候，它会变成 ADP， 然 E 跟零分间断掉之后会释放电，
然后
才可以使用。
那个东西是在人体细胞里做的事情，在人的消化系统。就比方说你吃香蕉，然后一根香蕉掉到你的胃里，就是这个过程比较接近是很自然的传承。然后你的香蕉，然后被消化的时候，那个消化里面的化学反应是你刚才说的但是真的有人会一边骑脚踏车一边吃。对。本人他叫什么名字？
魏恩礼，你说第二题吧？魏恩礼要去问。那他怎么说？哦，对，这是。
那你要来订正啊。好，我等下再请他订正。摩卡里等下我写下。你想动摩擦力？这是正向的。然后这样，这是 force。然后能量的话呢？但是我刚才在讨论的事情是摩擦力是不是保守力？摩擦力不是保守力的原因是什么？这个公式要印证。那摩擦力不是保守力的原因，应该是因为保守力它是一种只跟你的位置在哪里有关系。比方说位置是 X Y。所以我们在意的是他现在的位置，他现在不在位置对面，他现在的力度大小。可是对选而言的话呢，他跟他所在的位置没有关系。然后呢，他唯一的，他就是跟他的教授的关系，跟那个物体这么重要的关系。然后在一些比较高阶的分析里面，然后呢就想要跟速度。所以，那么摩擦力它跟位置本身，它就谢谢。你要记得这样讲。
可以问就是跟这个关系。
好啊。
这个公司是保守的应用。就比如说这个带过去会成立。
我现在不确定，因为我觉得这个范围太广大了。
这种力量也蛮重要的，就是 mgh 然后变成 mg 变成负的 mg。
这我不确定下真的很大，我现在没有办法下，因为我觉得力太多了，对，然后没有办法。
公司的会大。然后说这个再变大，比如说这样，然后再变回去。
我觉得这件事情我保守起见，我要回去查一下资料，因为我怕我现在上次回答的话，搞不好下次要查，有点麻烦。对，我回去再看一下，因为我觉得这东西要我需要稍微我要谨慎，因为我要谨慎，因为力这个东西，我觉得其实保守力它是
成本很少，所以这其实不是保守力的东西。然后在这些不是保守力的东西里面，搞不好有人在某种程度下，他们
我练算磁力的时候，这个也会怎么？就可能两个线圈，然后算这个位置，这个位置对定位好，然后加速它那个力，就是会这条是磁力，只是磁力也是保守力。
对啊，所以我就说啦，我刚刚就说的，我现在没有办法说他特别去一个结论，一定是投保守力，因为就是搞不好别的不是保守，就是保守力它本身好，我直接用麦克风讲。谢谢你问这个问题。关于那个保守力的。
About the definition of conservative force. The conservative force and the original definition is that the conservative force depends only on the position. So the position of your object is related to the force that it's experiencing, and it's only related to the position of it, and that is the character of conservative force. And here are a lot of forces that doesn't fit into this requirement, but they are still forces, and they are the non-conservative force. And the non-conservative force, they have a lot of, and there are a lot of members. It's a big family. So sometimes, I think people, to me, they can be a little bit annoying when they fix themselves into the definition of conservative forces and apply it everywhere and causes a lot of rows, and that makes me a little bit irritated, I have to say. So just keep just a reminder for you. 我刚刚有稍微说一下，就是保守力它最初始的保守力它的特征，它有个特征就是它的力的强度只跟你现在被受力的这个东西。它的所在的位置，就是它的位置会跟它受力的强度有关系。然后呢，它还有一个因为它只跟位置有关系嘛，所以你这样子绕一大圈回到原点之后呢，你的那个力是一样的，是不会改变。对，那这个是保守力本身的定义。可是当你对于物理的认识多了，你看过的力、处理过的力多了之后，你就会发现保守力只是这个力的大家族里面。就那么就那几个重力吧，重力有一个是重力，还有一个是电力，电力是保守力，还有哪一力是保守力啊 ？Fit into 那个基本粒子物理定那个反正就 standard model， 可以在 standard model 里面的力，他们基本上都是用保守力的想法去分析他们的，但其实不是保守力的力有很多，非常多。然后他们各自有各自的形态，然后他们有他们各自他们的能量跟他们的力之间的关系，各自有各自的，就是各自有他各自的形态啦。对，那我觉得有时候很多人他们就会用保守力的概念，然后去硬套到别的力上面，然后就会去批评说啊这个力是怎么样，然后批评说那个什么观念是错的等等。然后就知道大家就会纷乱，对啊，我就觉得有时候遇到这种问题，我会觉得蛮烦的。对，那所以就是其实这个问题是简单，它就是力有很多，保守力就那么几种，然后保守力它符合的条件是这几个，对，然后那别的力有别的特征，不需要一直不需要混为谈，然后也不需要就是用别人的标准，然后去互相批评。好 ，OK。那么就是先这样。哦，好。 And now we start the derivation. Okay. So we just mentioned work. So where does this concept come from? So actually it comes from the Industrial Revolution, when all the engineers, when they are trying to use machines to do something for them, and that is the reason why we call this quantity work. And when they are using this machine to push heavy stones or to lift it or to transfer some heavy things, or when they are trying to build ships or when they are trying to build cars, they really care about how effective the force is. So this is James Watt. He is the inventor of the steam engine. So this is the questions that he is having at his time. So that's, imagine here we have, this is the case that we are doing. We have a crane, and this is something to lift the stones up or to let it down. Okay, and so here are the parameters that we have right now. So the first group of factors, which is related to the weight of our stone. And the weight is the mass of the stones multiplied by the gravity. So this is the force that we should apply. And then here is another factor. This is the displacement. If you just lift it a little bit, or if you need to apply your force for a really long time and to lift the stones to a very high position, so that is the displacement along the direction of the force, so delta x. Here are the three parameters which is related to your problem. So the mass, yeah, you can imagine it. The gravity, you can imagine it. And then the displacement. This is related to how much effort that you have to put into it. And now we are trying to describe the effort into numbers. So work, this is defined by the effectiveness of an action. So you're doing an action and how effective is it? And this is related to the three parameters we just described. It's related to the mass, the acceleration, and displacement. And then you can transform it into the equation f multiplied by delta x. And be careful. Now the delta x must be along the direction of force. 所以这边有一个大重点，就是呢，你的位移的方向跟你的力的方向要是平行的，就是 by definition。一定义上来讲，如果你想要知道你现在做这个动作，它的效率有多高的话，然后呢，你的力跟你位移的方向一定要是一样的吧？如果不一样的话，你就做白工了，对啊，所以这就是为什么你的delta x跟你的力一定要是平行的。好 ，this is definition of work. And here now we try to turn it into the vector forms. Now we are using the vector analysis to do it. So here we are moving the blue box from the initial position to the final position. And this is the delta vector r. So this is the displacement. And here we have a force dragging the box. But the force is not on the horizontal plane, it's a little lifted, and the lifted angle is theta. And be careful, we just defined that work is the multiplication of the force on the displacement. And then you have to be careful that the force should be decomposed into a component which is along the delta r and another component here And this component doesn't really contribute the work for the movement. So now you have to put a cosine theta here to project the force on the horizontal plane. So this is work. Okay, and here we do it with vectors. So we have to introduce scalar product. So this is the definition of scalar product. If you have a vector A and another vector B, and you just take the magnitude of A and magnitude of B and then multiply it by the cosine theta. Theta is the angle between them. And the three typical cases. So when A and B are parallel to each other, then it's just, you just multiply them by magnitudes. And if they are anti-parallel, this is anti-parallel, you have to put a minus sign in front of it. And if they are in 90 degrees to each other, A or B, and here's a 90 degree, and cosine 90 degrees is 0, so A dot B is 0. Here are the three typical cases. So this is the scalar product, and the symbol is just vector A, and here's a dot and a vector B. And here's a little bit calculations. So A dot B and B dot A, it doesn't change anything. They are just equivalent to each other. So the projection on A or the projection of B on A, if you project the A on B, or if you do it another way around, if you project B on A, you just create exactly the same results. So we can think about it graphically. And here are another thing. So if you have a vector B plus vector C, and then if you do a scalar product here, then you just directly separate B and C, and then you can do it separately. So you can do it linearly somehow. We can do linear operation. So here are the properties. And now let's look at it in the coordinate system. This is the three-dimensional coordinate system, and we have x, y, z axes, and the unit vectors are I and j and k. Should I change the? Sorry, I have to change it a little bit. Somehow this is a little bit strange. I don't remember if I do it on purpose. Sorry. Let's move it. But in the equations, I just directly write half x. Yeah, okay. And here's the important property about the coordinate system. So if your vectors are on the same axis, and if you do scalar product of them, the unit vectors of them is just the 1. But if hat x and hat y, if you do a scalar product of them, you get 0. And this is why the orthogonal systems are very, very useful, because every time when you have a vector, you decompose them and then you put them into 3 axes, and then when you're doing multiplication of multiple vectors, and simply just check if all of these components are on the same axis. If they are on the same axis, and then you can just simply multiply them, and if they lie on different axes, then this is simply 0. 所以大家看到这个，你就会知道说，哇，为什么直角坐标系统这么好用？因为你如果向量嘛，你有很多个向量，如果你要做很多向量的内积的时候，那么呢，你只要把你的向量分解到 x、y、z 3个坐标轴上面，然后呢，你会有 x、y、z 3个分量。只要你的分量是在同个轴上面，你就直接相乘。然后如果它们是在不同的轴上面的话呢，就变成0，对你毫无影响。所以你用直角坐标系统，你在做很复杂的内积的时候就很好用，它不会把你的问题复杂化。好， And here, this is an example for you. So this is vector A and x, y, z magnitudes, and the hat x, hat y, hat z, and this is B. So you can read it. So A dot B is giving you this by applying this principle. So this is simply giving you the multiplication of all the components on each axis. And if you just simply take A dot A, so this is simply just the magnitude of A and it gets squared. So here are the skills that you can use. How大家可以用上一页的公式，然后你这边就开始用 A 跟 B 两个的时候。A 跟 B 的内积其实你就是把 x x y y z z 就把它相乘起来。那如果是自己对自己内积呢，你得到的就会是 magnitude 的平方。好，这个我们在之后的计算里面会常直接拿出来，用不会再对到。Okay. And here is a concept. When we are doing scalar product, and in fact, in reality, in the graphic, we are doing projection. 所以这里可以大家看到，你在做内积的时候，数学就是一个公式嘛。那实际上你在做内积的时候，你在现实世界你在干嘛？其实你在做的事情是你在投射，就是你现在有两个向量，然后你把其中一个投射到另外一个上面，然后你去量它的影子有多长，然后把那个影子跟被投射的两个相乘起来。所以任何你以后看到那个数学公式的时候，你只要看到 scalar pattern， 你就知道哦，现在有个东西正在做 projection， 你就要开始找说，那所以我投影的面在哪里，我是从哪里投影的，那你就可以阅读数学了。数学对你来讲就不只是公式，而是它是有意义，它有它的 intention 在里面。So now you can read mathematics. So every time when you see scalar product, then you can start to imagine, oh, now I understand here are two vectors, and now I'm projecting one another. So why I'm doing this projection, and what is the reference plane, and where do I do the projection? Then you can read mathematics, and then you can understand why the reader do it that way. And then it's so the mathematics is just not just an equation, and you can understand the intention. And here's the projection. So this is a vector A, and then if I do the projection, you can imagine here's a light from the top, and then you just shine the light on it, and the blue vector here, the blue, can I call it vector? So the blue shadow of vector A here, this one, and this is the magnitude of them is the magnitude of A and cosine theta. So this is the projection. This is exactly what I mean. And every time when you are doing vector decomposition into the three vectors, into the three axes, and actually you're doing projection on the three axes. 所以大家以后你在做那个向量分解的时候，你就会知道说啊，其实你在做的事情就是投射，你在寻找你的向量投影在 x、y、z 三个轴上面的影子。好 ，OK。And now we just analyze simple system with constant forces. So what about varying forces, and what about the deformable system when the things changes form, and how does the work is calculated? So now we have to do a little bit more derivation. So here is the situation that we have. We are moving something. So this is the position of our, say we have a heavy box and we are moving it. And this is the position of the box. And this is the force that we apply on them. This is the force, sorry. This is the force that we apply on them. And it's changed at every different position. So force on x direction, right? Okay, so now the force is changing like that. It doesn't have any regularity. And so let's do it this way. We just divide the distance into little pieces, and we calculate every little step I take and what is the work that I've done. So this is a little piece of work that I've done. So So this is the force that when I apply on it, when my finger is on the position X, and this is the little step I take, and I have a little piece of work. And then the total work will be the summation of all of this little work from the initial position to the final position. And in calculus, in the senses of calculus, what you're doing is you are calculating the area under the curve of your force. 好，所以这个应该是大家都还蛮熟悉的概念，应该不需要特别解释了。所以他要说的就是呢，如果你的横轴是位置，直的轴是你在你施加的力，好，就是你的东西在这个地方的时候，我给它多少推力，然后呢，我就把 force versus x 这个 curve 下面的面积我把它算出来，我就知道我总共做了多少功。好 ，OK。And here's the form in integration. So if we take the delta x, we take the limitation and we take it very, very small. And then actually you can do the integration. So this is f on the direction x. And dx, this is your little pieces of step. And you integrate it from the initial point to the final point. Okay. And how about multi-dimensional space? If we do it in 3 dimensions, then please do it this way. So this is the vector of S. This is the vector of your displacement. And we just do a scalar product of it because only the force on the parallel direction is counted in the number of the work. So you can do a scalar product of it, and just remember the equation: the head x dot head x and y z that is 0. So you can just take that. This is the work done on the x-axis. This is the work on the y, and this is the work on z. You just do them separately. 所以大家可以想一下，我们刚刚那个公式，你现在在直角坐标系统里面，那即使说你现在是在3维空间里面处理这件事情，你的力有一个向量，然后你的位移有一个向量，然后呢，我们的 work 我们只算跟力同方向的位移，就是你的位移跟你力要同方向，你的 work 才算数。那这个时候呢，你就可以使用内积来描述这件事情。那么你在做这件事情的时候，你就会发现，所以我只要把3个轴向上的功分开计算就好了，在 x 轴、y 轴、z 轴上面的功，它们之间不会互相影响，就是它们各自独立运作，这就简单了。所以以后你看到 vector f dot d vector r 不要害怕，你知道它是内积，你就把它分开，在3个轴上面处理即可。And another point of view is, now you can see that I am projecting my force onto my displacement. This is how I read it when I see this equation. 然后你也可以用另外一个方法去想，像我现在的话，我看 paper， 我只要看到 F dot dr， 我就知道所以我现在要把我的力，我把它投影到位移上面。And how about deformation? And we just start from the simplest deformation. This is the spring. And of course we have complicated deformations in 3 dimensions, and you have to operate it with tensors. But all of the tensors, they start from the 1 dimension. They are the combination of 1-dimensional deformations, and which is based on Hooke's law. And I think we don't need complicated explanation here, because everybody already knows it. So here's just a little recap. This is the case that when we just put the spring there and if we do not touch it, and then here's the original length of your spring, and this is the point that we call it equilibrium. So it just stays there, and if you don't touch it, it doesn't move at all. And if the spring deforms this way, if your block moves to the right hand side and if the spring gets longer, or if you do it another way around, if the spring gets shorter and the blocks move to the right hand side, and the force required is proportional to the displacement, which is x in this case. And the force is always in opposite to the direction of displacement, so that's why we have a negative sign for the k. And k is the Hooke's constant. This is 胡克定律, and this is vector form. This is nothing really special, just specify the direction of it. Okay, and then we go on. But just be careful. In reality, the Hooke's law can be applied in a very limited cases. So it only applies when your deformation is small. So it only applies when your delta x is small. So this is the range. Sometimes we call it, the spring has a linear behavior. So sometimes when the spring is working, like how Hooke just predicted, we call it is working in a linear region. But when the displacement is larger, then you can see, wow, there are so many different possibilities. And different kind of materials have different curves here. So the people in mechanical engineering, they have a full handbook of this plot, and they look at the shape of the curve to judge what kind of material is it. And the places like this, and sometimes we call it non-linear behavior. 这应该大家也都知道了，但就是跟大家说一下术语。就因为胡克定律呢，它能够适用范围其实很小，就是甚至我在博物实验的时候，我还蛮鼓励我的学生，你就自己试一下啊，你试一下你的弹簧，它的适用的范围有多少。对，那只要超出胡克定律适用的范围，然后那个我们会叫它非线性行为。对，就胡克定律的那个行为，我们会叫它线性行为。然后，当你的力跟你的位移就已经不成正比的时候，我们会叫它非线性行为。好，然后呢，我们通常在进了研究所，或是在你开始念博，甚至你会念博士的时候，我们就很少会再研究线性行为了，因为那个是基本款。我们通常会拿一些非线性行为的，我们会在非线性行为的地方工作啦。对，不管是力学，然后光学、介电值等等，我们都会对非线性的行为比较有兴趣。And this is the work done by the spring. We just simply apply the same definition. So the work done by the spring, this is the force and the displacement. We do a projection of the force on the displacement and make sure they are parallel to each other. And then we do an integration from the beginning to the end. And now the force is minus kx. And because we restrict ourselves in one-dimensional systems, this is fact x. And inner product and dx, initial, final. And then we can do the integration. We have 1 over 2 kx. And then we start it. The story starts. The initial point is minus x maximum in this plot. So we can put the minus x max inside. And then you get your final answer. So this is the displacement here, from minus x max to x equal to 0. And here's an equation that I take from the table. You can just apply on it. And this is work done by a spring. This is 0 point. This is on 2 different directions. And if the point is non-zero, then you can use this equation. And here's another thing. So you can see that the work here is only related to the position, right? X initial, X final. And if somehow, this is a little bit counterintuition, but if you just simply follow the equation like a dummy had, then you can see that the work is 0 when your spring started from the initial position and get back to the final position. The work turned into 0. And this is the character of a conservative force. 就是有时候我到现在看到这个，我还会觉得怪怪的。但是呢，如果你就是头脑你就直着，然后你就顺着定义走的话，你就会发现你的弹簧，假设它从缩的最小的地方开始被拉得长长的，然后噔回到原点，你感觉它好像已经做了很多事情了嘛。但是如果你跟着那个公式走的话，你就会发现，相对起来，你就像没做工一样。这个就是保守力的特征。但如果你是一个很有现实感的人，你看到这个 situation， 你意见就会很多吧，你就会觉得说怎么可能？一定中间有发生很多事情，怎么可能做白工？什么摩擦力啦，然后温度的影响啦，然后等等等等。这个也是常常理论跟现实会起冲突的地方。好，so what am I doing here? Oh, now I'm explaining the isolated system. Okay, so we just have 5 minutes left. We just come back to the little boxes at the beginning of this lecture. So now we can see that I am moving my little box with a pushing force. So this is the black vector. And here is a little tilted angle. And this is the force that actually pushing the block to move. And here are some components of the force that causes the friction. And now I would like to do a definition. Before I start my analysis, now I am setting a boundary for it. So I just pick that this is my boundary, marked by the dashed line. And remember that the boundary is the creation of a human. So creating a boundary is an art. If you put your boundary right, and you can simplify your problem. And how you set the boundary is not like a rule or something. That is a lot of creation. There is a lot of room of creation to play. 好，然后我特别强调就是呢，你在界定一个封闭系统的边界，这个就是这是一个你可以发挥巧思的地方。我在这边不要头脑僵硬， 就是并不是说你的 boundary 一定要是什么什么什么，然后僵持不下，没有必要这样子。好，就是每一个人在分析他的题目的时候，他有他的目的，于是他设定了这样子的 boundary。那我们可以欣赏大家先设定 boundary 的方法，然后不需要坚持说一定要这样子才是对的，等等，这样子就有点心胸狭隘。我会特别这样子讲，是因为网络上面就常常会有人为了这种问题，然后就吵一大串，然后就会有学生拿那种网络对战文来问我，然后我刚开始我会看一下，但是看完之后我常常都会觉得很空虚，对，所以我特别要说一下。所以你如果有发现这样子的事情的话，那就请你把注意力放在分析一下每个人他界定 boundary 的观点。然后你去分析一下那些不同的观点，欣赏一下，你就享受这样子的乐趣就好了。好 ，OK， 再来，然后 and here is okay. So inside my boundary, this is the system. So this is where I define my system. And outside the system, we have the environment. Okay, so here are terms: systems and environment and the boundary. And then this is the force that applied, and this is from environment to my system, and this is called the external work. 好，那么在我现在设定的这个界限里面呢，我圈起来的地方是我的盒子，然后呢，还有盒子本身里面的东西。然后呢，我施加的力并不在我圈选的范围里面，我目前把它归类在 external work 外部的力。好 ，and then go on. So I apply the external work to my system. Then my system starts to move forward, and then the work that I've done from the external world turned into the kinetic energy. This is from the movement of my box, and the friction can create some heat, and then the energy is leaking out of it in the form of heat. And here's the point that I usually cause browse. So what about the heat? So some of the people, they let the heat get out of the system. So here they just open the boundary and let the heat get out. And some of the people, they keep the boundary. They always keep the heat inside. So they extend the area of the boundary and always contain the heat. So here are usually two types of perspectives. Both of them are right. 好，那这边是通常会产生争议的点，就是呢，你的摩擦之后产生了热，有的人在这个时候就会非常开心的把他的 boundary 打开，然后让那个 heat 跑出去，所以这个是其中一种观点。然后有另外一种观点呢，就是呢，他会 always 把那个 heat 包在他的 boundary 里面，然后他把 boundary 的范围扩大，然后就是一直都把 heat 包在里面。前一种的想法呢，就是它的 energy 就不会 conserve， 就有一些热就会有些能量就用热的形式跑出去。那第二种观点呢，它就可以继续使用 conservation of energy law。因为对他来讲，他的 boundary 就是永远都把那些热圈在里面嘛，然后即使我的热一直不停的跑走，那我的 boundary 就继续拉大，把你包在里面就好啦。所以第二种想法的人呢，他如果有必要要使用 conservation of energy 的话，他就可以使用。我会特别讲这件事情，是因为常常会因为要可不可以使用 energy conservation 就吵起来。对，但其实真正的问题是在于说你的 boundary 是怎么设定的，你设定的 boundary 跟你的目标有符合吗？对，所以就是这样子就可以了。Okay, so then we just finished our lecture here today, and from Friday we start to derive the kinetic energy. 我们今天上课先上到这里，然后呢，下次我们再开始推导动能。 哦，还有那个第二题有一个要订正的地方，这边就是动摩擦力的话，就是它的公式不是这样，它的公式是蓝色的，是 mg 是正向力，然后 μ 是摩擦系数，然后摩擦力后的公就是后面这个，就需要订正同学自己订正。然后今天来报告的同学，然后还有帮忙订正的同学，就是记得来加分。今天3个。